Hello everyone, welcome back. Today we'll be doing exercise 7.3 of integration chapter. So take your books and pen and let's do the sums. So the first question here is sine squared 2x plus 5. You have to integrate this. So what we are going to do is first write down the formula of sine squared theta. It is 1 minus cos 2 theta by 2. Integration of sec square theta is tan theta. Integration of cosec square theta is minus cot theta. So these are the two trigonometric functions whose integration we know directly. But we cannot integrate sine square theta directly. So first we have to substitute this formula. Same way for cos square theta, we will have to write 1 plus cos 2 theta by 2 and then integrate it. And for tan square, we can write it as sec square theta minus 1 because we know the integration of sec square theta. And for cot square, we can write cosec square theta minus 1. So this is how we'll convert the functions first, except for sec square theta and cosec square theta. Rest all will have to convert the functions first and then we can integrate. So in this question, because we have sine square 2x plus 5, let us convert this to cos applying the formula. So we have integration 1 minus cos, double the angle, and over here our angle is 2x plus 5. So this becomes integration 1 minus cos 4x plus 10 upon 2. Integrated individually. The first value is, say, half will take common. The first term is 1. The second is cos 4x plus 10. Now you can substitute 4x plus 10 as t and do it. Or we can also do like this. Integration of 1 is x and integration of cos is sine. And in the denominator, we will differentiate 4x plus 10. In integration, the only variation allowed in the variable x is instead of x, you can have ax plus b. Then you can apply the chain rule in the denominator. So we have this is half x minus sine 4x plus 10 and derivative of 4x plus 10 is 4. And you can multiply that half in the bracket. So this is the integration of the function sine square. So whenever you have sine square, apply the formula 1 minus cos 2 theta by 2 and integrate it. Let's do the second one. Now because we have sine 3x into cos 4x, we will apply the formulas of 2sc is s plus s, 2cs s minus s, and 2cc is c plus c minus 2ss is c minus c. So we will be applying this formulas whenever we have the product of the trigonometric functions. So since we have 2 sine and cos, the formula is sine plus sine. So it is sine of addition of the angle plus sine of subtraction of the angle. If you are clear with the formulas, quite easy. So we have sine 7x plus sine of minus x. Also we know that sine is odd function. That means the negative sign will come outside or it will become minus sine x. Now what is the integration of sine function? It is minus cos. And like the previous question, because this is 7x, the variable is x, we will differentiate 7x in the denominator. Integration of minus sine x, one more minus sine, so plus cos x. And of course, the integration constant is there. Now instead of having two trigonometric functions, we have 3. But anyways, we can first apply the formula of 2cc in any of the two functions first. So I'll take this together and leave cos 6x for the time being besides. Integration of 2cc is c plus c. So we have cos of add the angle plus cos of subtracting the angle 2x minus 4x is minus 2x, and we still have cos 6x there. So this is half integration cos 6x, and cos being an even function, meaning cos of minus 2x is cos 2x. So we have cos 2x as it is, minus sign will just vanish. So we have half integration cos square 6x plus cos 2x into cos 6x. So once again we have to apply the formula. Over here cos square and over here 2cc. So one more 2 we will divide and multiply and then apply the formula. So our formula here is, because we already have this 2 here, it will become 1 plus cos double the angle 12x. Over here it is 2cc, so adding the angles and then subtracting the angles. Now again we are going to get minus 4x, but we know cos is even, so minus 4x will become 4x. So I'll remove this bracket. Okay. So now we integrate, we have x, cos integration is sine, but because this is 12x and this is x, we'll differentiate 12x in the denominator. Same for this one, sine 8x upon 8 and sine 4x upon 4. And obviously our integration constant c. Now since we have sine cube theta, let's find out what is sine cube theta. Sine cube theta is 3 sine theta minus sine 3 theta the whole upon 4. This formula we have got from sine 3 theta. Okay, I hope you know that. Sine 3 theta is 3 sine theta minus 4 sine cube theta. So we have simply rearranged this to get sine cube theta. So let's apply the same formula here. Our theta is 2x plus 1. So the formula is 3 sine theta minus sine 3 into the angle the whole upon 4. So first of all, let's take this 1 by 4 outside the integration, and now we can integrate this. So this becomes integration of sine 2x plus 1, which is minus cos, integration of sine is minus cos, so minus cos 2x plus 1 and derivative of 2x plus 1 in the denominator. This is cos 6x plus 3 upon 6. Now this is one question which can be done in many different ways, so our answer may not be exactly as it is given in the book, but on simplification you will get the value. So suppose if we rewrite this as cos of 3 into 2x plus 1 and apply the formula of cos 3 theta. What is the formula of cos 3 theta? It is cos 3 theta is 4 cos cube theta minus 3 cos theta. And so putting this formula here, we have 1 by 4 into minus 3 by 2. This value will remain same. Over here 1 by 6 into 4 cos cube of the angle is 2x plus 1, it is 3 theta, okay, minus 3 cos 2x plus 1. we need to simplify this. 6 we will take in the bracket, and also this 1 by 4. So we have 3 by 8 cos 2x plus 1, and if we take this 4 in the bracket, we will have here 1 by 24. So let's simplify this now. So this becomes 1 by 6 cos cube 2x plus 1, 1 by 8 cos 2x plus 1. Now two terms with cos 2x plus 1. Simplify that. It becomes minus 4 by 8, which will be minus half. And this cos cube term is only one term. So that's our answer. That's one way of doing it. Another way of solving the same question is, instead of applying the formula for sine cube theta, we can write this as sine 2x plus 1 into sine square 2x plus 1. And so, this is sine 2x plus 1, and this is 1 minus cos square 2x plus 1. So, if we substitute cos 2x plus 1 as t, the derivative will be minus sine 2x plus 1, and applying the chain rule, differentiating 2x plus 1, we have into 2, and so minus sine or sine 2x plus 1 dx will become minus half dt, and we put that here. Sine 2x plus 1 into dx is minus half dt. What is this value? 1 minus cos 2x plus 1 is t, so we have t square. Now we simply have to integrate this. Minus half, integration of 1 is t, and minus minus plus, integration of t square is t cube by 3. And so that is why our answer becomes minus half. Put back t. What is t? Cos 2x plus 1 and t cube. So that's an easy way of doing. Just split this sine cube as sine into sine square. In this question, we'll try to apply the method which we did in the earlier one. Any one of this you can write in terms of the other function. So I'll write here cos square x into cos x. So what is the formula for cos square x? It is 1 minus sine square x, because we don't want to convert it to another angle, we just want everything in terms of sine. So that we can substitute sine x as t, and so cos x dx will become dt. So this is dt, and rest all sine x is t. T cube into 1 minus t square dt. Open the bracket and integrate it. So what is the value for t? It is sine x. So whenever we have sine and cos or simply sine, we can think that the power for cos is 0, and if you have simply cos, you can think that the power is for sine is 0. Okay, and that way you can convert one to the other function, substitute and solve it. So for this question, we will have to recall back those formulas, one of which was minus 2ss is c minus c. That's what we are going to apply here. So I'll divide by minus 2 and multiply by minus 2. Any two functions you can combine again. So I'm combining the first and the second. The formula is c minus c. Add the angles and subtract the angles. And for cos, we need not worry. Even if you have a minus sign, we know it is going to get removed because cos is an even function. So this will become cos x. We have cos 3x into sin 3x, taking this in the bracket, and this is minus cos x into sin 3x. As we said, cos of minus x is cos x. So this minus will remain as it is. Now we are having the formula cos into sine. Now over here you can directly apply our formula or identity which we know, that is 2 sine theta cos theta is sine 2 theta. And for the other one, 2 cs is s minus s. Let's put these formulas here. But for that we need one more 2. So I am dividing by 2 again, and this will become 2 sine theta cos theta, which is sine double the angle, this one. And this is 2 cs because we have multiplied by 2 now. Okay. So what is the formula? Sine add the angle minus sine subtract the angle. So this is sine 6x minus sine 4x. Now we know sine is an odd function, so this minus sign will come out, this will become plus and one more minus. So actually we have minus, minus and minus 3 times, so it's minus 2x. Now integrate it. Integration of sine is minus cos. And because this 6x doesn't match with our variable x, so differentiate it in the denominator. Minus cos. Same here. And you can take minus 1/4 in the bracket. Once again we have sine into sine, so applying the same formula. Divide by minus 2 and multiply by minus 2. If you don't want to multiply and divide by minus sign, that is minus 2, what you have to do is you can take the same formula, only thing first you subtract the angles and then you add the angles. Okay. So I want to keep it regular, that's why I have multiplied and divided by minus 2. Now first add the angles and then subtract the angles. Once again, as usual, we know cos is even function, so minus 4x will become 4x. So we have integration of cos, which is sine, and because minus 12 and x, differentiate minus 12x in the denominator. Same for the other one. So this is easier than the previous question. So these are 7 questions for today. The next ones will be taken up in the next video. Thank you.